In this video, we solve stoichiometric problem. Aluminum reacts with bromine and form aluminum bromide. So the moles are 2 moles of aluminum always combines with 3 moles of bromine to form 2 moles of aluminum bromide. So always the reactant and product, they always form in the same mole ratio. So we convert into moles to do the calculations for how many reactant or product are formed. So like in this question, how many moles of bromine are needed to produce 5 moles of aluminum bromide? So aluminum bromide is 5 moles. And how many moles of bromine? So they're asking number of bromine. So the mole ratio is 3 moles of bromine forms 2 moles of aluminum bromide. This is the mole ratio. Okay, always the reaction will go in the same ratio. So 3 moles of bromine forms 2 moles of aluminum bromide. So first we write what is given. So given is 5 moles of aluminum bromide and required is how many moles of bromine. Moles of bromine we have to find. So first we write given amount. So that is 5 moles of aluminum bromide times mole ratio. So mole ratio is 3 moles of bromine and 2 moles of aluminum bromide. Because here aluminum bromide is at the top numerator, so we down also we write aluminum bromide first. So 2 moles of aluminum bromide and 3 moles of bromine. So this is the mole ratio. So this is mole ratio. And this is a given amount. So given times we write mole ratio. So whatever is given here, we write in the denominator same reagent. Or whatever we have to find, it should be on the top. Like how many moles of bromine? So 3 moles of bromine. So we have to write the one which we are calculating at the top. So now calculations, moles of aluminum bromide cancels. So 3 times 5 is 15 upon 2 moles of bromine. So answer is moles of bromine. That is 15 over 2 is 7.5 moles of bromine. So given amount times mole ratio. So whatever we have to find, we write at the top that one. For example, next question. Ammonia plus oxygen plus methane. We'll erase this one. Ammonia plus oxygen plus methane, they form hydrogen cyanide and water. So now the question is how many moles of oxygen are needed to react with 1.2 moles of ammonia. So given is 1.2 moles of ammonia and what we have to find required is moles of how many moles of oxygen. So we write given amount times mole ratio. So given amount is 1.2 moles of 1.2 moles of ammonia times mole ratio. So mole ratio is ammonia and oxygen. So this is ammonia and oxygen. So because here ammonia is at the top, we write below ammonia. So 2 moles of ammonia. So 2 moles NH3 requires 3 moles of oxygen. So 3 moles of oxygen. So now moles of ammonia, they get cancelled. So 1.2 times 3, 3.6 over 2 moles of oxygen. And 3.6 over 2 is 1.8 moles of oxygen. This is the answer. Next question is B part. How many moles of water can be expected from the reaction of 12.5 grams of methane? 1.2. This is sorry. Twelve point five. So how many moles of water can be expected from the reaction of 12.5 moles of methane? Okay, now their given amount is 12.5 moles of methane. And what we have to find that is required. How many moles of water? So we have to find moles of water. Now they are comparing water and methane. So from the equation we know moles of methane and water. So what is the mole ratio? So this is methane and water. So first we write given amount. So 12.5 moles of methane times mole ratio of methane and water. So methane is here, so down we write methane. So 2 moles of methane makes 6 moles of water. 6 moles of water. This is the mole ratio. From the equation we know the mole ratio. Now moles of methane cancel. So 12.6, 12.5 times 6, 7.75 divided by 2. That comes to 37.5 moles of water. So this is the answer. So same with this equation, 2 moles of ethane on combustion forms 4 moles of carbon dioxide and 6 moles of water. So methane undergoes complete combustion to produce carbon dioxide and water. How many moles of oxygen are required to react with 13.9 moles of methane? So first always we write given amount. So given is 13.9 moles of ethane and required is how many moles of oxygen? So we have to find moles of oxygen. So now they are comparing ethane and oxygen. So this is ethane and oxygen is this. Okay, the mole ratio is 2 moles of ethane combined with 7 moles of oxygen. So first we write the given amount. So that is 13.9 moles of ethane. So 13.9 moles of ethane, C2H6, times mole ratio. So here ethane is at the top. So we write first ethane. So 2 moles of ethane requires 7 moles of oxygen. If they are asking how many moles of oxygen, always whatever is asked, it should be at the top. Okay. So we have to find moles of oxygen. So I write moles of oxygen at the numerator and denominator we write ethane, moles of ethane. So moles of ethane cancel. So now we have 13.9 times 7 divided by 2. So use calculator and find 13.9 times 7 divided by 2. It comes to 48.6. 65 or round it to 48.7 moles of oxygen. This is the answer. Next B part, how many moles of water will be produced by 1.5 moles of oxygen and sufficient ethane? So first we write what is given. So given is 1.5 moles of oxygen and required is how many moles of water? We have to find moles of water. So now they are comparing water and oxygen. Water and oxygen. So in the mole ratio, we'll take ratio of water and oxygen. So water is 6 moles of water and 7 moles of oxygen. So first we write the given amount. So 1.4 moles of oxygen times mole ratio. The mole ratio is, we have to find moles of water. So moles of water are 6 moles of water and required 7 moles of oxygen. Always this unit and this unit should be same so that they get cancelled. So moles of oxygen cancel. So 6 times 1.4. So 1.4 times 6 divided by 7 equals to 1.2 moles of water. So this is the answer. So like this, we can solve stoichiometric problem. So given amount times mole ratio. So if you have any question, please write in the comment. And if you like this video, please like, share, and subscribe to our channel for more videos like this. Thank you.